This video is going to take you through the different pieces of graphing. First thing that we're going to do is just look at how to find the x-intercepts. Like before, if it doesn't show up in the table, we are going to have to solve. This will bring us back to some of the stuff we were doing with the basics of logarithms and solving equations. So our first step is to set y equal to 0. So we'll do 0 equals. If you don't like the equation in this order, you can always make it equal to 0 on the right side. I'll do that on the next one just to show you what I'm talking about. Now we do need to isolate the logarithm first, so anything surrounding it, like a negative sign or adding, subtracting, we're going to remove first. Now you're not used to seeing it this way because most of the problems I did where the log was on the left, so I'm just going to switch the order just to make it easier to see. And to solve an equation like this, you're just going to switch it to exponential form. 3 to the negative 3 equals x minus 1. Calculate that and add the 1. Now you could really do it all in one shot. Type in your calculator 3 to the negative 3 and then add the 1. I'm going to show what that comes out to be here. At the end, I would put this back into fraction form. So you're typing in 1 divided by 27 plus 1, math, enter, enter, and it's going to give you 28 over 27. That would be your x-intercept. Remember when writing these points, you would write those values, comma 0. Now with the natural log, it's going to be the same thing. Again, I'm going to switch it so that it's on this side here. Now remember, the natural log is really log base e. So when I rewrite this, I'm going to rewrite it that way so it makes it easier to change over later. And I would always do that with the natural log if you know you're going to be solving an equation. Let's add the 2 to both sides first. Divide by the negative sign, so we'll just divide that out and we'll get negative 2. Switch to exponential, so e to the negative 2 equals x plus 4. And then again, you can put that in all in one shot, e to the negative 2, and then we're going to be subtracting 4 from both sides in that case, minus 4. And on this, I'm okay with you leaving it as a decimal because you can't put it into fraction form. So let's do negative 3.86 for this x-intercept. Again, that's going to be something we'll have to do only if it does not show up in the table. I think a lot of the examples we will do, we will have to find those values. I kind of picked them on purpose that way so that we can practice. Alright, so our first graphing example will be almost identical to what we did with the exponential graphs. We're going to list our transformations, so this is translate right 1 and up 2. Only difference is the starting table. So before, when we did our starting table, we did negative 1, 0, 1 in the x column. We're now going to put that into the y column because it's reversed. And then we're going to put the 1 over the base. So in this case, our base is 2. 1 over 2, 1 and 2. You're still going to do the transformations the same way, so add 1 and add 2. Get your new table. So it'll be 1.5. 2 and 3, and then 1, 2, 3. Now the difference with the vertical asymptote is going to be the horizontal translation. So we went to the right one. That's going to be your vertical asymptote, x equals 1. So make sure you identify the horizontal translation correctly. That's where you're going to put your asymptote line. So that's going to go right here. Just like before when we, the vertical asymptote goes on the horizontal translation spot. Just like when we did horizontal asymptote, we did the vertical translation. We're going to plot the 3 points. So 1.5, 1, 2, 2, and 3, 3. Connect them and label. A little hard for me to label on here, even with my little pen, so do the best you can with seeing that. Our domain is going to be 1 to infinity. You can wait until you graph it to see that. Again, that's going to match up with the asymptote, like the horizontal asymptote and the range matched up last time, and negative infinity to infinity for the range. The x-intercept is something we do have to find. So we're going to do log base 2 of x plus 1 plus 2 equals 0. Subtract the 2 from both sides, so we'll get this is equal to negative 2. Switch to exponential form to solve that, and calculate 2 to the negative 2. Oh, I put a plus 1 instead of a minus 1. Let's fix that real quick. It's like real class where I make mistakes. Alright, there we go. So we're going to do 2 to the negative 2 plus 1, and you can put that in the calculator all in one shot, and you will get 5/4. Or 1.25 would be fine because that is an exact value. So just like before, if it comes out exact in the decimal format, you can use that. Alright, so we're going to keep going in this video. It's going to be a little longer because we're going to do 2 more graphs. If you need to pause, kind of make sure you get everything down, then please do that. Our next graph will be similar. And then the last one we'll switch over and do one of the E graphs, but it'll be kind of the same thing. So here we have a reflect over the x-axis, a left 2 and a down 3. So with this, just like before when we do the critical points, you want to, let me make that too big because I'm going to need some space to do the x-intercept later. You're going to do negative 1, 0, 1, 1/3, because the base is now 3, 1, and 3. You want to do a reflection table first. Some of you before were doing the reflections in the original table, which is fine. Just be careful and make sure you do it to the correct column and that you don't switch it back. So it's going to be these 3 points. You're just switching the y column again like before. They're different values, so just don't get confused by that. And then we're going to do minus 2, minus 3 to get the left 2 and the down 3 part. And that's going to give us negative 1 and 2/3, negative 1 and 1, and then negative 2, negative 3, negative 4. I'm going to wait to label those points A, B, C. I think it's going to go in the same order, but we just want to be careful. We went to the left 2. So again, that's going to be your vertical asymptote, x equals negative 2. Make sure to make this a dashed line. We're going to plot the points. Negative 1 and 2/3, negative 2, negative 1, negative 3, and then 1, negative 4. Just like before, you want to get close to the asymptote line. Don't go back away, and then we're going to label the 3 points. And these actually, because it's a reflect over the x-axis, will still go in the same order. Again, we don't know our x-intercept, but we can do the domain of negative 2, infinity. Again, notice I'm highlighting that in the color. Negative infinity to infinity. And then we're going to want to set log base 3 of x plus 2 minus 3 equal to 0. Do a little solving work. Kind of run out of space here, so we're going to have 3 to the negative 3 equals x plus 2. So you want to type that in and subtract the 2. That's going to give us 55 over 27. Beautiful number, as usual with these, and that one would need to be written in fraction form. I'm just going to write the other option also for the domain that x is greater than -2. Remember, you want to use greater than in the parentheses because it doesn't actually go through the vertical asymptote. Alright, so we have one more graph to do. Again, if you need to pause it, take a quick break and then come back, you can do that. This next one is going to be a natural log. So we're going to have with this a reflect over the y-axis and a translate down too. Just like when we did the e-graphs, we're going to use the approximate information here. Since we don't go left or right, the vertical asymptote will stay 0. That's important. And when we go to do the critical points, remember it's log base e of x is the same as natural log of x. So we're going to use the points -1, 0, 1 in the y column, 1 over e, which is 0.37. Let me just double check that. Yep, comes out to 0.37. 1, and then e, and again you can type these into your calculator. E is about 2.72. That's going to be in your x column. Now we reflect over the y-axis is going to make all of the x column negative. We'll keep these guys positive. Now usually I recommend doing that in a separate table. If you did it all in one shot, you actually would be okay in this situation. But as usual, just be careful because it doesn't always work for every situation. So it'll be -0.37, -1, -2.72. And then we're going to have -3, -2, and -1. Put on our asymptote line. Again, it's hard to draw it when it's right on there, so you can do that either a little bit to the left or a little to the right. -0.37, -3. Again, that's the estimate. -1, -2, and then -2.72, -1. Again, an estimate point. Get that close to the axis, and then going straight away. As like the other three graphs, we do not have the x-intercept, so we are going to need to calculate that. Make sure your labels match with the graph. And the reflect over the y-axis is going to be a little different. We're going to be going -infinity on the domain to 0. Range is still -infinity to infinity. And then we're going to want to set, I'm going to make it log base e right away of -x minus 2 equals to 0, because we are going to be switching this to exponential form to finish up this last piece. So it'll be e squared is equal to the -x. So when you calculate, you'll just do -e squared. And that's going to come out to -7.39. Okay, so the graphing for this is very similar to the graphing for the exponential. Again, the difference is going to be that your table is flipped. So be careful with that. Make sure you start off with it flipped. And then do all the operations the same way that you would have done them before once you identify the transformations.